the 4th power times the natural log of x, and you're asked to evaluate this using integration by parts. Okay. So, how do we do that? How do we apply integration by parts to this? Yeah, we need to figure out what to let u equal and what to let dv equal. So what should we let u equal for this one?
Natural x.
Yeah, we can let u equal the natural logarithm of x, and then dv.
X to the 4th.
Right, x to the 4th dx. All right, and then what's du? Right, 1 over x, because that's the derivative of the natural log of x. Of course, at the end we have dx. And then what's v? Yeah, we take the integral of x to the 4th, so it's x to the 5th over 5. So now how do we apply integration by parts? So u times v, so we have natural log of x times x to the 5th over 5 minus
the integral of x to the 5 over 5 times 1 over x.
Right, so we take the integral of v times du, so that's x to the 5 over 5 times 1 over x. All right, so we've got x to the 5th over 5 times the natural log of x minus, and now what's the integral, what's x to the 5th over 5 times 1 over x? What would that simplify to?
X to the 4th over 5?
Yeah, x to the 4th over 5.
So I something on one of the other problems we did. How do we get to x to the 4th?
That's x to the 5th divided by x. So we're just canceling out a factor of x. All right. So to finish, what is the integral of x to the 4th over 5?
And it's an x to the 5 over 25.
Yeah, we're going to get x to the 5th over 25, right, because the integral of x to the 4th is x to the 5th over 5.
So x to the 5th, right?
Or 5th, right, over 25.
Plus c.
Plus c at the end, right. So that's it.
That's it?
Yeah, that's it.
And we just keep doing it until we can get something that we can take the integral of?
Yeah, so if the first time you apply this, you don't get an integral that you have a formula for, then right, you can try integration by parts together. All right. So any other questions on that?
Can we do 2a?
Yeah, so in number 2, you've got integrals involving trigonometric functions. So for 2a, we have the integral of sine cubed of x times cosine to the 4th of x. All right. So how do we start with this one? Well, we could take out sine of x. Of course, why would we take out sine of x?
Because it's a negative. Or it's an odd number, like, because it's sine to the 3x, right?
All right. So we take out a factor of
Sine, because you want to make it close.
right. We want to be able to put it in a form where we can do a substitution, and in order to do that, we have to have the derivative of one of the functions in the integral. And so if we take out the sine of x, of course, what's that the derivative of?
Negatives, wait,
Yeah, negative cosine of x. So what's the derivative of cosine of x?
negative sine.
Negative sine of x. So we would actually want to factor out negative sine of x. Now, of course, that will leave us with what? Sine squared of x times cosine to the fourth of x. And since we inserted a negative on the inside, what do we have to do to balance that? Now put a negative on the outside. All right, so now what do we do?
We can change sine squared of x to 1 minus cos to 2x.
Right, we can change the sines to cosines.
Yeah.
So sine squared of x is 1 minus cosine squared of x. So now we've got the integral in terms of cosines. So now what do we do?
Now, don't we change it to like do u and du?
Yeah, we'll make a substitution. We'll let u equal what?
Cos x.
Right, cosine of x, and then what's du?
Negative sine of x.
Right, negative sine of x dx. So what would this integral be in terms of u?
You'd FOIL it out to be u to the 4 minus u to the 6.
Right, so after you multiply it out, replace u by cosine of x, right, you get u to the 4th minus u to the 6th.
That d d d.
And then du, right, because that's negative sine of x dx. All right, so what is the integral of u to the 4th minus u to the 6th? Right, u to the 5th over 5. Right, minus u to the 7th over 7. So now how do we get the final answer?
Put cosine back.
Yeah, we can put cosine of x back in place of u. Of course, we can also distribute the negative. So what do we end up with?
Cosine to the 5th over 5.
So negative cosine to the 5th over 5,
And then is it plus?
right, plus,
Cosine to the 7 over 7.
right, cosine to the 7th of x over 7. And then at the end, plus c. So that's it.
So when you originally picked cosine as the u, how did you know to do that?
Well, because we want to be able, if we're going to use the cosine as a cosine of x as u, we need to be able to write, after we factor out the derivative, we need to be able to write the rest of the integral in terms of cosines. We can do that if we start out with an odd power of sine, because in order to change the sines to cosines, we need to have an even power. If you factor out one of the cosines, you're left with an even power, so you can apply sine squared equals 1 minus cosine squared. So remember with sines and cosines, you see if one of the powers is odd. If one of the powers is odd, then that tells you which factor to factor out. And then whatever function that's the derivative of, that's what you're going to substitute. So we factored out the sine, or negative sine, because sine was to an odd power. And since that's the derivative of cosine of x, we use the substitution u equals cosine of x.
I have a question.
Yeah.
So whenever we got 1 minus cosine squared of x times cosine to the 4th of x. So I know we substituted u.
Right.
Where do we get the u to the 6th?
Well, that's from, we actually combined two steps here. So you can replace cosine of x by u, so you have 1 minus u squared times u to the 4th. This is what you get when you multiply it out.
Because you have the exponents. It's 4 plus.
So if you do this substitution, you have negative integral of 1 minus u squared times u to the 4th. And so this is what you get when you distribute.
Oh, and the d. Okay, I see where du came from too. Okay.
Yeah.
Okay, yeah, because that's what I was confused
Any other questions?
Yeah. Could you do 2B?
All right, so 2b is the one where we have secants and tangents. So we have secant to the fourth of x times tangent of x dx. All right, so what can we do with this one?
Can we
In terms of sine, cosine.
Well, you could, but you can actually do this without changing it to sines and cosines. It'll probably be easier just to leave it as secants and
do
tangents.
you take out the secant squared of x?
You could take out secant squared of
Are
x.
there like multiple ways you can, like 2 ways you can do this?
There's
one?
actually more than one way this one could be
Okay, I was
done.
wondering.
But yeah, if we factor out secant squared of x, of course, we're left with secant squared of x times tangent of x, and then times secant squared of x. So now what do we do?
You write it in terms of tan?
Yeah, of course, secant squared of x is the derivative of what? Tangent of x. So we want to get this in terms of tangent of x. So how do we do that?
1 plus tangent of squared x?
Right, secant squared of x is 1 plus tangent squared of x. All right, so we got the integral of 1 plus tangent squared of x times tangent of x times secant squared of x dx. So now what do we do?
Replace tangent with u.
Yeah, we can let u equal tangent of x, and then what's du?
Secant squared.
Right, secant squared of x dx. So now what's this going to be when we write it in terms of u?
U plus u squared.
And of course, we're going to have 1 plus u squared times
Oh, okay. Times u.
u.
So it's u plus u to the u cubed.
Yeah, and of course, secant squared of x dx becomes
du.
du. So right, if we multiply it out, we've got u plus u cubed du. So now what's the integral of u plus u cubed?
U squared over 2 plus u to the 4 over 4.
Right, u squared over 2 plus u to the 4th over 4. Of course, plus c at the end. So if we get this back in terms of x, what do we end up with?
Tan squared of x over 2 plus tan to the 4x over 4 plus c.
Right, so tangent squared of x over 2 plus tangent to the 4th of x over 4 plus c. Yeah.
So whenever we factor out secant squared at the top, we would never factor out the other one because it's the same exact. What would happen if we were to factor out the other secant squared of x?
Well, then, see, the reason why we factored out secant squared of x is in order so that we can get the du. Secant squared of x is the derivative of tangent of x, so we factored that out so that we could make the substitution u equals tangent of x. There wouldn't be any reason to factor out secant to the 4th of x.
Yeah, I think I misworded it. So whatever, I meant like substituting. We substituted secant squared of x, and we got 1 plus the tangent squared of x.
Yeah, because secant squared of x is equal to 1 plus tangent squared of x. That's one of the identities.
Right. So why didn't we do the other secant squared?
Because we need the secant squared of x there so that we have du.
Well, we still multiplied it. So
Yeah,
our
I mean,
goal.
we have
yeah.
to, in order to make the substitution, we have to have not just the thing we're integrating, but we also have to have du in the integral. Because if we didn't have secant squared of x dx here, we wouldn't be able to put du here. So remember with substitution, if you're making a direct substitution like this, you have to have the derivative of your substitution in the integral in order for it to work. Now, we could have, instead of doing it this way, we could have factored out secant of x times tangent of x. Because that's the derivative of what?
Cotangent?
Not cotangent. Remember, secant of x, tangent of x is the derivative of secant of x. So if we had done that, we could have just done the substitution u equals secant of x. And that would have given us an answer that looks different, that would be equivalent.
So instead of, so it would turn out to just be secant to the third
Right?
in the original part, and then you would just
Right.
multiply it times secant times tangent?
Well, yeah, you'd have secant of x tangent of x dx separate, so that when you make the substitution u equals secant of x, you would get the integral of u cubed du.
Okay.
So you could have also done it that
But
way.
it would be the same format. You just replace it with u.
Right.
Okay.
So you get it in terms of u, take the integral, and then put the substitution back in to get it in terms of x. You would get something that looks different but is equivalent, or at least it differs from this by a constant. So it would be an equivalent answer. All right, any other questions on that?
Can we go over 3A and B? Because I'm kind of confused with the, like, how you do those types.
Well, let's go ahead and do 3A. Begin with. All right, so we have the integral of, it's 1 over x times the square root of 25 minus x squared. And you're asked to do this using a trigonometric substitution. Well, which trigonometric substitution are we going to use for this integral? Where we have square root of a constant minus x squared. Yeah, that's where we use u equals a times sine of theta. Now, in this integral, what's u? No, it's not 5. Remember, u is the variable part.
X.
Right, u is x. And then what's a?
5.
That's 5, because the constant term is a squared. So a is 5. So we're making the substitution x equals 5 sine of theta. Then what's dx? Well, not 1 over 5. We take, to get dx, we take the derivative of 5 sine of theta. Yeah, it's just 5 cosine of theta, d theta. And then if we take the square root of 25 minus x squared, so the square root that appears in the integral, what would that be? It's not 5 minus x. You can't take square roots by taking, you can't take a square root of an expression like this by taking the square roots of the individual terms, because square roots don't distribute. Yeah, you would just put a or 5 sine of theta in place of x and simplify, and what it would simplify to is, right, 5 times cosine of x.
Where do you get x equals 5 times sine of theta?
That's just using the fact that in this integral, u is equal to x and a is equal to 5. So remember, the form is square root of a squared minus u squared.
So it comes from the form.
Yeah. right, so when we make the substitution, well, of course, what are we going to have in place of x? Yeah, 5 times sine of theta. What are we going to have in place of the square root of 25 minus x squared?
5 cosine theta.
Right, 5 times cosine of theta. And what do we have in place of dx?
5 cosine theta.
Right, 5 cosine of theta d theta. All right.
That's the answer.
No, because we still need to do the integral. All right, so can we simplify this?
Can we multiply the 5s?
Yeah, we could multiply the 5's on the bottom. So we have 5 over 25. And of course, what would that simplify to? It would simplify to 1/5, so we can put that on the outside since it's constant. And then, what else can we do to simplify?
Wait, sorry, where did the 1/5 come from? We took out.
Well, we've got 5, which is going to go to the numerator, and 5 times 5 in the denominator. 5 over 25 we simplify to 1/5.
Okay.
We can cancel the cosines.
Yes, we can cancel the cosines, because we're going to have cosine over cosine. So that will leave us with 1 over sine of theta, which is what? Yeah, it's equal to cosecant of theta. So this simplifies to 1/5 times the integral of cosecant of theta. Now, what is the integral of cosecant of theta? Well, no, that's the derivative. We need the, well, I mean, it does involve cosecant of theta minus cotangent of theta.
It means
but
a natural log.
Natural log of that. So natural log of absolute value of cosecant of theta minus cotangent of theta. Right, plus c. Now, is that the final answer?
I imagine not.
Probably.
Well, the original integral was in terms of x.
X.
So we need to get the answer in terms of x. Alright? So we need to figure out what cosecant of theta and cotangent of theta are in terms of x. Well, how can we do that? Well, right, we can write sine of theta as x over 5. So now how can we use that? Right, so cosecant of theta is the reciprocal of that. So it'll be 5 over x. So we have cosecant of theta is 5 over x. Now how do we get the cotangent of theta?
I'll just sine over cosine.
Well, we could not sine, well, it's not
Cosine.
sine over cosine, right, cosine over sine. Now, of course, we have sine of theta, but what's cosine of theta going to be equal to? Well, it's not just 5. We can actually use this to get cosine of theta. Right, cosine of theta will be equal to, right, square root of 25 minus x squared over 5. Right, so to get cotangent of theta, we would have this square root of 25 minus x squared over 5 divided by sine of theta, which is x over 5. Okay, so can we simplify that a little bit? Yeah, we can cancel the denominators since they're the same. So cotangent of theta is equal to the square root of 25 minus x squared over x. Alright, so that's it. So remember, with the trigonometric substitution, you have to get it back in terms of x at the end.
But how come the square root is not a square?
How come what?
The square root goes to 25. Oh, it is still over there, never mind.
All right, any other questions on that one? Now for part B, where we have the integral of 1 over the square root of 16x squared plus 1 dx. Well, which substitution would we make for that one, where we have a plus instead of a minus? Yeah, it would be u equals a times tangent of theta. So in this problem, what's u going to be? Well, remember, u is the variable term.
4x.
Yeah, square root of 16x squared, so it's going to be 4x. And then what's a?
Square? Yeah.
Yeah, it's going to be square root of 1, which is 1. So it's just 1 times tangent of theta. All right, so since 4x equals tangent of theta, what's x equal to?
1/4 tangent.
Right, x is 1/4 tangent of theta. So what's dx? What's the derivative of 1/4 tangent of theta?
One-fourth secant squared.
Yeah, it's 1/4 secant squared of theta, d theta. And then the square root of 16x squared plus 1. What's that going to be equal to? Well, of course, since 4x is tangent of theta, 16x squared is going to be, let's see. Well, it's this squared.
Right.
So that's tangent squared of theta. And what's tangent squared of theta plus 1? Secant squared of theta. So when you take the square root, it's just equal to secant theta. All right. So to write this integral in terms of theta, or you're going to have 1 over what?
Secant theta.
Right, secant of theta. And then in place of dx,
1/4 secant squared theta d
right,
theta.
1/4 secant squared of theta, d theta. So what's that going to simplify to?
Wouldn't before go to the bottom of the secant?
Well, yeah, in fact, what can we do with the factor of 1/4?
Put on the outside.
You may just take it outside of the integral. And then what's the rest going to simplify to?
Yeah, just
1
secant.
over secant of theta times secant squared of theta.
Well, you're going to have secant squared of theta over secant of theta.
So secant.
So it just simplifies to secant theta.
D theta.
Right. So you would just need to integrate secant of theta, and then, like in the previous problem, get it back in terms of x at the end.
So this one is easy.
Well, I mean, it's from this point on, it's similar to what we did here. so I'll leave the rest of it up to you.
So, I remember whenever we first started all this, is U is equal to, like, remember how you said U is only equal to something and A is only equal to something? Because, like, so in the formula, it says, like, let's see, U is equal to A times of theta.
Right,
And
which is what we did here.
so in the formula, U is the second, like, it's A squared plus U squared.
Well, U is the, now, U is the variable, U squared is the variable term and A squared is the constant term.
Yeah, that's what I was asking, like, U.
Right, I mean, 16x squared plus 1 could be rewritten as 1 plus 16x squared if you want to get it in the form A squared plus U squared. All right, any other questions on that?
Could you do 4B?
All right, so number 4. So that's where we're using partial fractions. So yeah, let's go ahead and do that one. All right, so we have the integral of, it's 18 over, we have x cubed plus 2x squared plus 3x plus 6. Yes. Well, in order to use partial fractions here, what's the first thing we need to do?
Oh, is it something like you take the x, like you leave out the 6, and then you take the ones of x and like factor it or something?
Well, what we need to do is factor the denominator.
Yeah.
We need to make two fractions.
All I know is just a.
Yeah, so that we have we're gonna have a fraction in the decomposition for each factor. So how can we factor this?
Just taking out x out of
Well, we can't take out x because we can't take x out of 6.
Do you separate it from the 6? Like take an x out of the ones that have x and then add something?
That won't help. I mean, we can't complete the square here because of the x cubed term. How do we factor a polynomial when it has 4 terms? Or how do we try to factor it when it has 4 terms?
So we separated the parts.
Yeah, we separate it into 2 groups. So we separate the first 2 terms from the last 2 terms.
And then we factor.
Yeah, so what
that's
can,
if you factor 3 of them.
well, what can we factor out of the first 2 terms?
X.
All right, x squared, that's times,
X plus
right, x plus 2. And then what can we factor out of the last 2 terms?
3.
3, and that's times x plus 2.
So x plus 2 is one factor by itself.
Right, so we get a factor of x plus 2,
And x squared plus 3.
right, and x squared plus 3 is the other factor. So remember, this is called factoring by grouping. So you can use this method to factor a polynomial, or to try to factor a polynomial with 4 terms. I mean, it won't factor every polynomial with 4 terms, but occasionally it works. All right, so the factors are x plus 2 and x squared plus 3. So what does the decomposition look like?
Where did the x squared plus 3 come from?
The x squared comes from here, the 3 comes from
Oh,
here.
okay. Okay.
What we did here is factored out that common factor of x plus 2.
Okay.
All right, so what does the decomposition look like? So we have a over x plus 2 plus, well, we're going to have x squared plus 3 in the second denominator, but would we just have b there? Yeah, we have bx plus c. Remember, we have to have something of the form bx plus c if the denominator is as a second for each factor. All right, so now what do we do? Yeah, we multiply both sides by the denominator, which will give us what? So what will we have on the left? Well, by the whole denominator. We're multiplying both sides by x plus 2 times x squared plus 3. So we're just left with 18 on the left because it just cancels the denominator. And then on the right, we get a times what? Right, times x squared plus 3 plus, then we'll have bx plus c times x plus 2, right? All right, so we need to find the values of a, b, and c. So how do we find the values of a, b, and c?
Try -2 first.
Yeah, of course, what do we do with -2?
Put it into the x.
Right, so remember what we do is we'll plug in 3 different values of x into this equation. So right, we start with -2 because that will make this first factor equal to 0. All right, so if x equals -2, we have 18 equals a times what?
7.
All right, a times 7. Then we'll have, of course, what do we get for the second part? We'll
Did
have
you just
bx
get 0?
Well, yeah, it'll be 0 because this factor will become 0. So we just have 18 equals a times 7, so what's a?
A over 18 over 7.
Right, a is 18 sevenths. Now, what's another number we can plug in?
0.
Yeah, well, we can plug in x equals 0. I mean, there's no number that will make x squared plus 3 equal 0. But we can plug in 0 because that will at least make the b disappear. All right, so if x equals 0, we have 18 equals, and we already know that a is 18 sevenths. And then what will x squared plus 3 become? If x equals 0, right, it's 3. So we've got 18 sevenths times 3 plus,
0.
well, of course, b times 0 is 0, so, but we're still going to have the c. So we have plus c times what?
2.
Times 2, right? 0 plus 2 would give us 2. So now we can solve that for c. So first of all, what is 18 sevenths times 3? Well, let's leave it in fraction form.
7.
Well, what's 18 times 3? 54. So it's 54 sevenths. And of course, c times 2 is 2c. So what do we do next? Well, of course, how do we solve this for c? All right, and of course, how do we do that?
Subtract.
Subtracting it. So we need 18 minus 54 sevenths. Well, what's 18 minus 54 sevenths?
We have to multiply 18 times 7 and then
Right.
$72.
So it's 72 sevenths.
Yep.
72 sevenths equals 2c. So how do we finish solving for c?
Divide by 2.
Divide by 2. So that will give us c equals what?
72 over 14.
Which would simplify to?
36 over 7?
Yeah, right, so C equals 36/7. Alright. So we've got A and we've got C, so we need to plug in a third number to get the value of B. So what's a third number we could plug in? We could use x equals 1. I mean, there's no obvious choice, but 1 is an easy number to plug in. So if we plug in x equals 1, we've got 18 equals, so right, A is 18/7, and that's times what?
4?
Well, what's 1 squared plus 3?
4?
That's 4. So 18/7 times 4 plus, well, we've got b times 1.
B.
So that's b plus, and then we can put in the value of c, which is 36/7. Well, x is 1 this time,
Okay, times 3.
times 3. So we need to solve that for b. So let's see, what's 18/7 times 4? Right, 72/7 plus, and then we can distribute the 3. So we'll have 3b plus, and then what's 36/7 times 3?
108 over 7?
Right, 108 over 7. All right, so,
Combine my terms.
right, so what's 72/7 plus 108/7? Well, that's 180 over 7. Right. So now if we subtract 187 from 18, what do we get? So negative 54/7. So that equals 3b. So how do we get b?
Divide by 3.
Divide by 3. So what's negative 54/7 divided by 3?
Negative 54 over 21?
Okay, and what would it simplify to? So negative 18/7. So we've got b. So now if we put the values of a, b, and c into the decomposition, we have 18/7 over x plus 2 plus, and then negative 18/7 x plus 36/7 over x squared plus 3. We're taking, so we need to take the integral of that. All right. So what's the integral of 18/7 over x plus 2? We get 18/7 times the natural logarithm of
X plus 2?
absolute value of x plus 2, right? Now, how do we handle that second term? How do we integrate that second term?
Simplify the top?
Can't really simplify
Oh, it's
the
an X.
top
That means an
because
X.
they're unlike terms.
Okay. Can we get rid of the X at the top by dividing? So you only
No,
have-
because you'd have to divide both terms by x.
Oh, okay.
Remember, what we can do in that case is separate it into two separate terms. So we can separate this as minus 18/7 times x over squared plus 3. And then plus 36/7 times 1 over x squared plus 3. All right. So how could we integrate this first one?
Is it just x ln of absolute value of x plus 3?
Well, it is going to involve the natural logarithm of x squared plus 3. But in order to do that, what do we have to have in the numerator? Yeah, you have to have the derivative of the denominator. So what is the derivative of x squared plus 3? Right, so you're going to have 2x in the numerator. Of course, we can factor out the negative 18/7. But right, in order to have 2x in the numerator, well, since we had to multiply by 2 on the inside, what do we do on the outside? 2. Right, we're going to have 1/2. Now, of course, we've got a minus here. And then what's 18/7 times 1/2? Right, it'll be 9/7. And then when we take the integral of 2x over x squared plus 3, natural log of absolute value of x squared plus 3. So that's the integral of that term. Now, how do we take the integral, how do we take this integral? So we've got 36/7 times the integral of 1 over x squared plus 3. Right, it's the formula where you're getting the inverse tangent. Of course, in this particular case, what's u? Right, u is x, and what's a?
Three?
Well, a squared is 3.
Square root of 3?
So a is the square root of 3. So we've got 36/7 times, and then what's the integral? So what do we get for the integral of 1 over x squared plus 3 when we apply that formula? Formula is for the integral of 1 over a squared plus u squared du. So what was it equal to? 1 over a, inverse tangent of u over a, right, plus c. So what are we going to get? 1 over square root of 3, so that will put square root of 3 in the denominator. Times the inverse tangent of, right, x over the square root of 3. Then the plus c at the end. So that's it. All right. So that's the final answer there. So any questions on that one? If I give you one like this, I'll try to give you one where you're not going to get the fractions,
Right.
just to save some time.
Yay.
So the 36 of the 7 over 3, that should be multiplied, the 36 of 7 multiplied by 1 over.
Yeah, that's the 36/7 that you have to begin with, multiplied by 1 over square root of 3. Alright, so we have number 6 next, where you're evaluating integrals using integral formulas. There are actually four formulas listed there. Are there any questions on that one?
Are you gonna put the formulas just like that on the test?
Yeah, it'll be like this. I'll give you the integral to integrate, and I'll give you a list of formulas to choose from. You just have to choose the right one.
Are these the ones where we use like
So you're just finding the formula from that list that applies to that integral, and then use the formula to get the answer.
we just use that formula?
Yeah, so for example, if it's the first one where you have 1 over the square root of x times the square root of 10 minus 9x, and you look at these formulas, let's see, which formula is going to apply to that one?
Is it the third one?
Yeah, it's actually the third one, because notice that the x under the radical is not squared.
Okay.
There's no u squared in it.
So the third one, where's it
So it's the third formula here, where you have the square root of a plus bu. So once you figure out the formula that applies, you have to figure out what u is, what a is, and what b is in this particular integral, and then put them into the formula.
What formula do you use for the second one?
Let's see, we have 1 over x times the square root of 9 minus x minus 4x squared. All right, so which one would that be?
Can you use this?
Oh, what? Can you use the first one?
Yeah, it would be the first one, because
You just have to square 9?
because you have a constant term minus a
Okay.
squared term.
So u is the variable.
Yeah, so u would be the variable
Okay.
term, and then a is the constant term.
Can we do one of them?
All right, which, doesn't matter which one?
No, not really.
Let's go ahead and do the first one then. So it's the integral of 1 over x times the square root of 10 minus 9x. And we saw that it's the third integral formula listed here that we're going to use, because that's the one where you have a square root and there's no squared term underneath. All right, so the form is 1 over u times the square root of a plus bu. So in this particular integral, what's u? Right, u is x. What's a? Yeah, a is 10, and what's b? Well, it's negative 9 because it's minus 9x. All right. So now if we look at that formula, and notice this is one of those formulas where you have two different choices depending on whether a is positive or negative. So which one of those choices would we use for this one? Yeah, the one where a is positive, so the first one. So we have 1 over the square root of a. Then that's times the natural logarithm of, absolute value of, and then you have square root of a plus bu minus the square root of a over square root of a plus bu plus the square root of a, and then plus c at the end. So if we put these values into that formula, what are we going to get?
1 over square root of 10.
All right, 1 over square root of 10,
ln,
natural log,
absolute value, square
absolute
root.
value of,
10 plus negative 9x
So it's gonna be 10 minus, square root of 10 minus 9x,
minus square root of 10.
right, minus square root of 10 over.
Same thing as the top, but
right,
just a
so
plus.
Square root of 10 minus 9x,
Plus.
right, plus square root of 10. And then plus c at the end, so that's it.
Is the answer?
That's the answer.
That's it.
So, it,
Five is great.
it says A is
We had 5
less than
questions.
0. You just would switch if A was.
Yeah, so if a was negative, then you would use the second formula instead,
Okay.
the one with the inverse tangent.
Got it.
All right, any other questions on that?
Oh, can you go over 7, just like the trapezoidal rule?
All right. So yeah, number 7, part A, you're using the trapezoidal rule to approximate an integral. In part B, using Simpson's rule. So yeah, we can do that. All right. Yeah, we should be able to do that. All right, so remember the trapezoidal rule. Says that the integral between a and b of f of x dx is approximately what?
One half, delta x. And then
So f of a,
plus 2f x 1
right?
plus 2f x 2. And then all the way to,
Oh, yeah, to like X4.
yeah, f
Yeah,
equals
so
f.
2 times f of,
Don't you alternate between the 2s and
F
4s?
of,
well, not with the trapezoidal rule. That's Simpson's rule that you're thinking of.
Oh, okay.
With the trapezoidal rule, they're all multiplied by 2.
Mm-hmm. Oh, okay.
Yeah. Except for the first and last one. So of course at the end we have f of b. All right, so for this one, you're asked to evaluate this integral using n equal to 4. So if n is equal to 4, and this is for the integral of, or integral between 1 and 3 of e to the 1 over x squared dx. So we want n to be equal to 4. So how do we get the value of delta x?
3 minus 1
So 3 minus 1,
of,
so it's b minus a over,
of a 4.
right, over n. So we divide by 4. So what does that give us?
1/2.
Right, it gives us 1/2. What's that?
See why it's 3 minus 4. I'm gonna do.
Yeah, we subtract the limits of integration and divide by the value of n, and that gives us delta x. So now once we've got delta x, how do we get the numbers to plug into the formula?
So you use when you do your subdivisions.
Right, you find your subdivision point, so you're going to start with, of course, 1, your first limit of integration.
And
Then how do you get the rest?
then add the half to
Yeah, you just keep on adding delta x till you get to the other limit of
Oh, so you
integration.
get to 3, yeah, so 1, 1.5, 2, 2.5, 3.
Right, so you're going to have 1, 1.5, 2, 2.5, and 3. So those are the values that you're going to plug in.
And that's it. And once you like plug them in, you just
Yeah.
get
Right,
the
so
answer.
now just using the formula, we're going to have 1/2 times delta x, which is 1/2, And then we're gonna plug in 1 into the function, and of course, the function is e to the 1 over x squared. So that's gonna be e to what power?
1.
Yeah, e to the first power, if you plug in x equals 1. Plus, and then 2 times, and now you plug in x equals 1.5. So 2 times e to the 1 over, what's 1.5 squared?
3.
Well, it's not 3,
No.
it's 1.5 times 1.5. Right, it's 2.25.
Why is it 2.25?
Because that's 1.5 squared. We're plugging 1.5 in for x.
Oh.
All right, and then we're gonna have, now we're gonna have 2 times the function with 2 plugged in.
4, so it's e equals 1 over 4.
Right, so it's 2 times e to the 1/4.
And then this is the 2.5 squared,
Right, so now we're gonna, for the next one, we plug in x equals 2.5.
which is 1 over 6.25.
Right, so 2 times e to the 1 over
And
6.25.
then the last one is 2e 1 over 9.
Well, the last one, we don't multiply by 2. It's just gonna be e to the 1 over 9. All right. So you would just need to work that out on your calculator to get the answer.
So with Simpson's rule, it's like the same thing, but instead of alternating 2s, it's a 2 and a 4.
Right, with Simpson's rule,
We'll be going from 2, 4.
right. And remember, instead of multiplying by 1/3 of the, or 1/2 of the front, you multiply by 1/3.
Okay.
So it's 1/3 times delta x, and then you have, again, f of a, but right, you start, for the, after that, you're alternating between multiplying by 4 and 2.
Oh,
So you have 4 times f of x1,
Also, it starts with 4 first.
starts with 4, right? And then 2 times f of x2, plus 4 times f of x3, and
We'll be
so
plugging in the
on.
same numbers,
Oh my God.
because the only difference is we're multiplying by
Right, so you find the subdivision points the same way as before. The difference is the 1/3 in front and alternating between factors of 4 and 2. And of course, at the end, you just have f of b. So again, the first and last values are not multiplied by anything.
What is that is that the answer?
Well, the answer would be what you get when you work this out on your
Oh.
calculator.
Okay.
So you still have to work that out on your calculator to get the answer.
So,
So make sure you do bring your calculator.
Right.
uh,
That'd be rough.
For real?
Yeah.
so for the one right there, we plug in,
What?
we start.
I can hear you.
0 and we go to 6.
Right.
Oh, I will. I'm gonna upload it to
What
YouTube.
are the,
Okay, you
If
got
it works,
You
yeah.
got the other one when I wasn't here?
Well, you'd have to
I just did this
figure
one.
out delta x.
Yeah, that's what I'm
That's
saying.
real selfish. You.
That's the only one I
So
need.
remember delta x.
I don't need the other
b
ones.
minus a over.
Nobody needs the other ones.
So
Yeah, because it says.
This is the important.
subtract the limits of integration and divide by n. And that will give you delta x.
Do you have a video of last Wednesday?
This is the only time I ever take a video.
Well,
think
6,
it's
you
the
take
same.
6 minus
Yeah.
0.
I may have some
Which
pictures.
is
I did it.
6.
It's
I don't think I have
6, and then
videos.
you divide by n,
I think I have
which is
Which is
6.
6, which is 1.
So delta x would be 1. So what would the subdivision points be?
1.
Yeah, 0, 1, 2.
3, 4.
All the way to 6.
Oh,
6, right.
okay.
Right, again, once
Okay,
you've got
lost me there,
delta
thank
x, you get the subdivision points by starting at the lower limit of
Oh,
integration
so
and
it'll
repeatedly
be-
adding delta
So the
x.
second one is easier because you don't gotta do 1.5.
Well, yeah, that one you don't have, I mean, you have.
And
that
then we
one's
just
there
plug it
full
in the same
numbers.
equation and keep adding.
Right, you
and
just
adding,
plug your values into here,
Uh-huh.
and,
And keep adding.
right.
Oh, okay.
So what's the point of these? What are we getting? Like,
It gives you an approximate value of the integral.
okay.
So
okay.
these are examples of integrals that you wouldn't be able to integrate using the normal integration techniques. And so if you wanted to evaluate these integrals, you wouldn't be able to do it using the
Right.
fundamental theorem of calculus. So this just gives you a way of getting at least approximate values for the integral.
So Dr. Fletcher, for Simpson's rule, what are we plugging into the x's? It's like x1, x2, x3.
The subdivision point. So once you get your list of subdivision points, that's what you're using for A, x1, x2, x3, and so
So
on.
same for the Simpson's rule, right?
Right.
Okay.
So f of a is, which is 0